We've been practicing finding linear regression equations, or lines of best fit, based on data sets that we're given. And today we're going to practice the same here. So we want to find the line of best fit for the relationship between the total fat grams and the total calories for our various sandwiches that were collected. So here in our table, we can see the total fat and total calories. The total fat represents our independent variable, our inputs, our X values. And the total calories represents our outputs, our dependent variable, our Y values. So what we're going to do is we're going to take this data and review how to use our TI graphing calculator. I'll be using the 84 CE for the steps here. And then we'll also show you how to do it on Desmos.com/calculator if you need to use that as well. So again, the first important part was talking about the independent and dependent variables. We know what should go in for X and Y, or our list 1 or list 2 on the graphing calculators. So remember, list 1 are our X values, the independent variable, and list 2 is our Y values, the dependent variable. So we're going to go to the graphing calculator, and remember, to get to the list, we press the stat key and we press enter. If you already have items in your list, you're going to arrow up so the list name is highlighted, press clear, and arrow back down. Again, if you have things in the list that you're using, arrow up so the list name is highlighted, press clear, and arrow back down. Now we want to enter in our data values. So we said our total fat grams was our independent variable, our X's, and we're going to enter those in. And after we type each number, we press enter. So we had 5, 9, 13, 20, 21, 25, 28, 30, 31, and 34. Now we arrow to the right for list 2, and again, this represents our total calories for the sandwich. And again, we press enter after each entry. So we had 300, 260, 320, 440, 420, 500, 560, 530, 550, and 585. So again, at this point, you want to check and make sure you have the same number of entries in list 1 and list 2. This is critical because, again, if you have one column having more or less entries, it's not going to allow you to create your scatter plot. And also take a moment and double check that you have all the correct values entered for your inputs for list 1 and your outputs for list 2, because that would impact the equation you come up with. So at this point, we want to create the scatter plot. So to do that, we could press second, y equals, and we want to make sure we have one scatter plot turned on and the other ones are off. So if we press enter, again, we want one scatter plot turned on, and notice how it's highlighted. If you had multiple plots on, again, to turn them off, you would just highlight and press enter. But we're going to turn plot 1 on, so on is highlighted. The first option here with the dots, that's your scatter plot. And again, you're telling the calculator where you found your lists. So our X values, the inputs are in list 1, and our outputs, the Y values, are in list 2. I'm just going to use a box to represent my data points. You can choose what you would like. I would stay away from the last option because they're smaller in size and harder to see. And then if you do have the CE model, you could pick the color that you want. At this point, once you have the scatter plot turned on, you're going to go to the zoom key here and pick option 9 for zoom stat. This is going to automatically adjust your viewing window so you can see all the data values that you're working with. So now we want to tell the graphing calculator to create our line of fit. In order to do that, we're going to go back to the stat key, and this time arrow to the right to calculate. We're going to pick option 4, linear regression, that's written in slope-intercept form. Remember, A on our calculator is representing slope, which is typically represented by an M, and B is your y-intercept. So we're going to press option 4. And again, we tell it where to find the data. We had our X values in list 1, the inputs. We had our Y values in list 2, the outputs. We arrow down now to store regression equation. This is going to not only calculate the line of regression equation, but also put it in our calculator so it will show up on our graph. To do this, we press the vars key, which is just below your down arrow. We're going to arrow to the right for the y variables, y vars. And yes, it's a function. Each input had an output, so we press enter. And we want to store this in our graphing calculator's first equation spot, so y1, press enter again. Brings you back to your screen here, arrow down and press calculate, so you can press enter. And notice how it calculated your linear regression. So we can have our slope approximate, our y-intercept approximate, r squared, and r. So you would round your slope and y-intercept to whatever features they were asking you to do. And then we look at r squared and r. R is your correlation coefficient. That tells you the strength of the relationship based on the data points. Remember, very strong relationships are closer to 1 and -1. 1 represents positive relationships where both variables are increasing in tandem, and a -1 represents a decreasing relationship where the inputs x increase and the outputs y decrease, so they're not moving in tandem. The residual squared also tells you about the accuracy of your equation, and again, the closer that is, or the smaller amount that is, the less margin of error you have from your predicted values to the actual values. So looking at your R value, if it's 0.97, it's very close to 1, so we know this is a strong positive relationship or a strong positive correlation. The R squared value is very minimal as well, so we know that it's fairly accurate to the data points. And I believe for this problem, they asked you to round to the nearest hundredth. So when we write the equation, we would say y equals 11.63x plus 195.21. So now that we've gotten the equation and the correlation coefficient and the residual squared, we can actually look to see how close of a fit our line is to the data points. And so at this point, you can just press graph. And remember, you had your scatter plot with your data points, and here's your line of fit. Again, we want to see it going in the direction of the data points, splitting them about evenly above and below, and we would like it to have about 2 data points on your line of fit, and we're very close to that. And it's meeting all of the requirements then for your line of fit, the linear regression line. So now we can answer some questions based on having the line, knowing how they're related, the inputs, the total grams of fat, and the outputs, the total calories for the sandwich. Now, if you are using desmos.com/calculator to create your line of fit, these are your steps. So you go to desmos.com/calculator. You may have to log in with your Google login, which is fine. And we go to the plus sign. And to create our table of values, like the list, we pick table. Notice how it gives you the X and the Y, the inputs and outputs. So here we're going to enter our data just like we did on the graphing calculator. List 1 is now our X1, and list 2 is now our Y1. And again, you'd press enter after each value that you're putting in your list. So here we go. Our data was 5, 9, 13, 20, 21, 25, 28, 30, 32, 31, and 34. And you can always delete something if you made an error or if you have too many values. So again, do a quick check, making sure that you have all the inputs correctly into your table. Now you type in their corresponding outputs, again hitting enter after each entry. And again, you want to make sure, the critical point, do you have the same number of entries into your X column as you do your Y column, so that it can create your scatter plot accordingly. Now, depending on how you last used your calculator, it would adjust your window so you can see the data points. If you need to adjust it manually, what you need to do in the upper right-hand corner, there is a wrench. If you click that, here you can see the scale for the x-axis and y-axis that you can adjust for that. So we said our x values, we're going kind of from 5 to 34, so maybe you want to start at 0 and go to 40, and maybe you want to count by 5s or 10s. And then your y's for our calories, we kind of were, our lowest was 260, so maybe you want to start at 250, and our highest was at 585, so maybe you want to go to 600, and you can adjust your step, I think, by 25s, and then just press the wrench when you're done, and you can see now your data points, just like we did on the graphing calculator. So once you have that, what we're going to do now is tell it to calculate the line of fit. So we go back to the plus arrow, we're going to go to expression, and we're going to type in our format for our slope-intercept form. We're going to tell it to use these data values. So we're going to use the y1, so we're going to type y and press number 1, and then we're going to approximate the line of fit. So you're going to use the tilde icon. So if you press shift and the button above tab, there's your tilde, approximately. And then we want our slope-intercept form. So that's going to be m. We're going to use the x value, so we're going to type x sub 1 plus b to represent your y-intercept. And notice here, it's calculated your line of fit, right? Here's your slope, here's your y-intercept. See how it's very similar to what you did on the graphing calculator. And you have your correlation coefficient r and your residual squared here as well. And you can use that data then to construct your line of fit, just like we did before. We said it would be y equals 11.63x plus 195.21, and do your approximations with that. So again, we have our equation. We talked about the correlation coefficient and the type of correlation that exists between the total fat grams and the total fat calories for the sandwiches. Now we can do some predictions since we have an equation based on the information given, whether it's the total fat grams or the total calories. So for example, if a sandwich has 470 total calories, how many total fat grams would you expect it to have? Well, we're given 470 total calories, and we know that total calories is our y, right? That's the output. So if we substitute 470 into our equation for y, we should be able to undo it to solve for x. Well, to undo this equation, we would subtract 195.21 from each side, and then have to undo that multiplication of 11.63. So we're going to divide each side by 11.63, which leaves us with 23.63. That's 23.63 total fat grams we should expect the sandwich to have if it has 470 total calories. So in this problem, they gave us the output. We had to find its corresponding input based on our equation that we came up for the line of fit. And again, the R value is close to 1, so this should be pretty accurate to what the actual value would be if we had a sandwich to test that was 470 calories. Now, if we had a sandwich with 15 grams of fat, how many total calories would you expect it to have? Well, 15 grams of fat is our input. That's our x value. So if we substitute 15 in for x, we can just evaluate our equation now and find the total number of calories. So we take 15 times 11.63 and then add 195.21, and that would give us the total calories we should expect the sandwich to have. So we would expect the sandwich to have about 369.66 total calories. So this is what we've been practicing with creating the lines of regression based on data and doing the applications, whether given an input value or an output value, to find a predicted outcome based on the line of fit that we created. So you're going to do some more practice problems with creating your lines of fit and your predictions to prepare for your assessment for next class.